This podcast is about stoichiometry in the lab and calculating theoretical and percent yield. So what we've been doing so far when we calculate how much product should get made in a reaction, that is theoretical yield. So that's what we've been, if you calculate it, it's theoretical. If you do the reaction in the lab, the amount that you actually do get, the number of grams, is the actual yield, and then the percent yield is actual divided by theoretical, and then times 100 to change it to a percentage. Most reactions are not 100% because of experimental error, things that are not perfect in the lab, purifications, filtrations, transfer, things like that. Spills, side reactions. So when we say A and B react to make C, sometimes they can also make something else, which lowers the yield. And sometimes the reactants are not pure, so we assume that they are 100%, and they are not. First example, silicon carbide is a ceramic material. It's made from solid silicon dioxide, SiO2, reacts with carbon, powdered carbon at high temperatures, and it makes silicon carbide, SiC, and it also makes carbon monoxide. So here we are given the theoretical yield, which is 72.9 grams. Usually we are going to calculate this number. So then when the reaction is done in the lab, an actual yield of 51.4 grams of silicon carbide is obtained. So the percent yield is the actual yield, 51.4, divided by the theoretical, times 100 is 71.51%. So this is a more typical reaction. Calcium carbonate marble, CaCO3, reacts with hydrochloric acid to make calcium chloride in solution, aqueous, as well as water and carbon dioxide gas. So the first step is to calculate the theoretical yield. We're given the reactant, 10 grams of calcium carbonate and excess HCl. Because one of the reactants is in excess, we know that this is not a limiting reactant problem. If it were a limiting reactant problem, we'd be given starting amounts of both calcium carbonate and HCl. But here we're told that HCl is excess, so we only have to do one stoichiometry problem. So the first step is to use the 10 grams of calcium carbonate and calculate how much calcium chloride we should be getting. And usually this is not spelled out, but you do have to do it. So typical stoichiometry problem, convert from grams to moles, followed by the mole ratio. Starting with grams of calcium carbonate, convert to moles. The mole ratio is 1:1, so that's pretty straightforward. And then convert calcium chloride back to grams to get the theoretical yield. So this is the number that's going to go on the bottom of our percent yield calculation. So theoretical yield that we calculated first, 11.9. The actual yield has to be given. One of them has to be given. We calculated 11.9 grams theoretical. The actual yield is 8.25, and then the percent yield is 74.39. So this question is a little bit different. In this one, we're told that gallium metal is heated with oxygen and it forms solid gallium-3 oxide. So the first step, you have to start with a balanced equation. So if you're not given a balanced equation, you have to write one from the information that you're given. So gallium metal plus oxygen makes gallium 3 oxide, which is Ga2O3, and then the equation is balanced, and then the molar masses of each formula is calculated. So here we're told that 20 grams of gallium is reacted, and here we're given the percent yield, so we're not going to calculate the percent yield, we're given the percent yield, and then we are asked to calculate how much gallium 3 oxide will actually be formed. So we're going to calculate the actual yield. However, the first step is to calculate the theoretical yield. We're given the amount of reactant that we're going to start with. So stoichiometry problem, starting with 20 grams of gallium, convert to moles, mole to mole ratio, back to grams of the product. 53.77 grams is the theoretical yield of gallium oxide. That's how much we should be getting. And that number is going to go on the bottom. And this time we know the percent yield, and we're going to calculate the actual yield. So 75% is the percent yield, therefore it's 0.75% of the theoretical yield, 53.77, so we actually get 75% of that, which is 40.33.